Hi everyone and welcome to a new episode of MAHLE Mobility Talks as part of this year's IAA Transportation. Air conditioners. In this hot summer, we've all experienced what great inventions they are. If you don't have one, you have to put more effort into cooling your house. You have to close windows and shutters during day, and during the night you have to open them and the doors to create a fresh air circulation. And that's it. That's the magic of thermal management. While we've mastered the absolute basics, the mobility industry is working on new sustainable and efficient solutions. What is upcoming here and what innovations can we await? That is what I'm talking about right now with the Vice President Engineering Thermal Management at MAHLE, Dr. Roger Busch, who was laughing hard when I said, okay, this is the magic of thermal management. But it is, actually, that's basically it.
Yeah, sounds quite interesting. I was thinking what I'm doing the whole day, if it's that easy. So
Yeah.
but
Let us figure that out later. But first of all, I've just suggested my hack for, let's say, cooling your house. Do you have any thermal hack in our everyday's life, like cooking or, I don't know, showering, where you say, okay, this is a very good idea to really get the energy into a good flow?
yeah, basically thermal management is everywhere around us, and basically it's really about heating and cooling. And because we are talking about the mobility sector, it's all about how to do this in the most efficient way. And I think everybody experience cooling, like you just mentioned, inside of the cabin. So when we are talking about air conditioning, but you have to think about in a vehicle, we are also talking about cooling the engine, or in the future the battery, or other components which need to be cooled. In parallel, we are talking about cooling inside of the cabin. And on the other hand side, we are also talking about heating, because you just mentioned the summer, which was quite hot, but what do you think about driving a car in the winter without having any heating? And that will become quite more complex in the future when we are talking about battery electric vehicles.
So it's all about the balance of heat and cold, I guess. Since we're here in our IAA edition here at MAHLE Mobility Talks, what is it about the transportation field? Is it the same? Is it easier? Is it more tricky with thermal management?
I would say it this way: it's getting much more complex. Let me give you the example. In the past, when we had a combustion engine in the vehicle, basically a combustion engine everybody experiences is getting hot, and you get basically the heat from the engine free of charge, and you can use the heat from the engine to heat up your cabin. When we are talking about a battery electric vehicle, there is no more engine. So the question is, how do you generate the heat for the compartment in a battery electric vehicle?
I forward this question back to you. That would be my next question. So some people say that thermal management is even more crucial in terms of e-mobility than a battery. So why is that?
It will become, because I think there were a lot of media reports about that the driving range of battery electric vehicles in winter times are getting smaller and smaller. Basically, why? Because in the past, the energy which you have on your vehicle, which is basically stored in a battery, was also used to heat up, for example, the cabin or other components who need the energy. And that is not the most efficient way of generating the heat. So what we are doing, but today I think we talk more about trucks, but maybe coming from the passenger side, it's all about how to generate really the energy and collect the energy from various sources, because the combustion engine is no more there. But you have, for example, inverters, you have e-motors who are also generating a certain kind of heat. And the question is how you can use it the most efficient way. And then we're really talking about a combination of both of the systems. In the past, it was really about cooling an engine and making a cabin comfort in the compartment for the passenger. And in the future, it's no more only about the passenger, it's also about the battery. Because the battery also likes to have a certain kind of a temperature window to operate in a decent way. Now it's no more just about heating and cooling the compartment for the driver or the passenger in the car. Now it's also about how to provide the heating and the cooling for the EE infrastructure, which is basically the battery and your motor.
So are these the most critical parts in terms of thermal management when it comes to efficiency, or are there other, let's say, big obstacles to solve when we talk about real efficient electric vehicles in terms of thermal management?
I think basically thermal management is one of the decisive factor in the future for battery electric vehicles. It really determines at the end of the day, there are different components, but that is one of the major part which determines also at the end of the day your overall energy consumption of the vehicle.
Mm-hmm. And what can you do to tweak really the efficiency with thermal management, let's say in terms of the battery or the whole ecosystem of an electric car to increase efficiency?
So if we're talking car, which is maybe not so relevant for the truck, but if we're talking about car, I think a good example, everybody knows it, and now we have a lot of discussion in the media how we use also in our homes the energy in the most efficient way. And I think everybody knows heat pumps from home appliances where we are using heat pumps, which is basically you're not just using the electric energy for heating, you're collecting also the energy which is in the outside air or in the water, and you use this energy to heat up. And that is more efficient than just what you may basically know from a water heater. If you just put a water heater inside and you just use the electric energy. So it's then what we call the coefficient of performance. So basically it's about that you use really the energy, which is outside in the air, and you pump it up via an e-compressor to heat up your cabin. And that's much, much more efficient than just putting just an e-heater inside of the cabin to heat up the cabin.
Mm-hmm. Speaking of heat and electricity, when I charge, for example, my smartphone or anything else, I recognize that a lot of times, or not every time, but a lot of time, it's getting real hot. So since you're the pro in terms of thermal management, what do I do wrong, and why is it that it's getting so hot every time?
Basically, your iPhone or your phone, not just this type of phone. It's not using it has a battery management system, but it does not have a thermal management system. What we see
at least not a smart one.
No, and in basically in battery electric vehicle, and I think that's a really good point and quite interesting one. When we are talking about fast charging, it's really about that the battery is heating up, and the question is how can you maintain the battery temperature in certain temperature profile so that you can really do fast charging, so that you may just wait 10 to 15 minutes to get 80% of your state of charge back in the battery. What we do for that is we have an active cooling inside of the battery, which is differently to a mobile phone. So you can think of it's like in an engine where you have a water cooling circuit to cool the combustion engine. We have now cooling circuits inside of the battery. We are talking about battery cooling plates, we are talking about intercell cooling, and the speciality in this case is you have to try to get as close as possible to the cell where basically the temperature is generated, and there you push basically the cold water through the battery to cool down the battery. But the interesting question is, where is the cool water coming from? And let me give you an example. You just mentioned this year's summer, quite hot. If you're driving at 30, 35 degrees to a hypercharging station, and you have a battery electric vehicle, and you really want to do fast charging, but you don't want to drink coffee the whole time, so you want to sit in your car, and you want to do hypercharging. Now, who is deciding, do you get the air conditioning in your car, or are you cooling your battery?
Hopefully you, and you say, I'll take care of Sarah.
That's about thermal management. What we have to do is we have to provide, on the one hand side, the cooling performance for the compartment, and in parallel also cool the battery during hypercharging, right?
And you've mentioned that it's not the big topic for trucks here. Is it easier or is it more difficult? So why isn't that a topic for the trucks?
We have to separate. I was talking about the heat pump system, which we use for passenger car, is not really that relevant for trucks. Simply because the energy which you need for the heating up and the cooling of the cabin compared to the drivetrain is quite low. So therefore, the heat pump system is not really relevant for trucks. But of course, what is really relevant for trucks is about how to do the cooling in a battery electric truck. If we're talking for medium heavy duty trucks, where we foresee there will be a certain volume also with the battery electric vehicles. And for trucks, I think, and that's a big challenge, the systems are getting much more complex, because in past cars we see a certain kind of mainstream where the whole industry is moving to. If you would ask me today, and my crystal ball in this regard is a little bit milky, about what will be really the share of which drivetrain in the future, that's quite difficult. That means we, on the other hand side, from the thermal management side, we have to provide solutions for combustion engines, for battery electric vehicle trucks, but also in the future for fuel cell trucks, which is quite getting even more demanding and complex in regard of the overall systems structure.
So that means a lot of work and a lot of technology to provide and to develop in the end. Let us get back to my cell phone for just one moment, because it's not just about fast charging and about using a battery, it's also about the life cycle of it. And that, I guess, there's thermal management also a crucial thing, because I looked up how often can you charge your smartphone, and it's they can withstand up to 2,000 charging cycles. That means if you charge your phone twice, you can use it for 2.5 or 3 years. That's not quite a long time for vehicles, and even more not for trucks. I guess they want to use it longer. So how can you have an impact with thermal management on the life cycle of a battery?
If you provide the right climate for the battery. It's like humans. You don't want, if you sit in your car, you don't want to drive your car in winter at 5 degrees, and in summer you have 35 degrees. And the battery, to have a good operation of the battery, you also have to maintain a certain kind of temperature window. And this is exactly what we provide with our thermal management system. Basically, that the battery feels good, and in different use cases. You mentioned before the topic of fast charging. So what we provide for doing fast charging, the battery has to have a certain temperature level. So that means, it sounds maybe a little bit weird, because I was always talking about cooling. But if you drive to a charging station, we normally even precondition the battery. This means we heat up the battery to have a certain kind of temperature, so that the energy flow is getting easier to the battery, while during the hypercharging, then we have to start cooling the battery. So you need both.
Yeah, it's not an initial energy you need to get the charging started.
Right.
Okay, got it. And speaking of that fast charging, a lot of experts on the market say that this is really a stress test, especially for the battery cells, and can lead to the problem that they wear out faster. From a thermal management perspective, is that true? Is fast charging something we should desire, or is it like, oh goodness, hopefully we won't be able to fast charge in the future?
First of all, you have to maintain this certain temperature level, and then it will work, but you have to keep the temperature. Otherwise, you will anyhow get a derating, because the battery starts to overheat. And that's exactly the speciality, how to design the thermal management system to provide enough cooling performance also to your battery during the hypercharging, so that it's not heating up.
So I guess you have some IT specialists around you, because that sounds like you need a smart system, and that means a lot of sensors, a lot of IT in there. How do you solve this problems?
It's about, at the end of the day, it's really about the control of both of the different systems, and it's really about balancing the energy flows inside of the system. And basically, when we are talking about cooling performance from the refrigerant circuit, we are talking about having an e-compressor inside of the system, which provides basically the cooling performance. And then we have to balance, are we giving more of this cool energy to the evaporator to cool down the cabin, or do we put it to the chiller to cool down the battery?
So you're in charge all the time while developing a car, because it affects so many parts of the
Right.
of the car, and especially also of a truck. It's
Yeah,
just
right.
for basically for every
Right.
vehicle. But is the old know-how from the combustion engine helpful for the electric vehicles, also especially trucks, or do you have to start from scratch? Because it's a whole new ecosystem if you use, for example, battery electric vehicles, and it's completely different thermal management there.
No, I think well, luckily we have a lot of experience in the field of thermal management systems, and of course we can use some of the experience and know-how what we have, especially when we are talking about heat exchanger, because at the end of the day you need some kind of heat exchangers. All of them are heat exchanger, be it to collect energy from outside, be it to provide cooling performance, which is then an evaporator to the cabin, be it to cool down the battery, which is then basically a chiller, which is basically from the design derived even from a oil cooler topology. So yes, we can use some of the building blocks what we learned in the past. I think what is new, and that's a challenge, what we see is to combine now the system. So it's no more, in the past it was more about developing a component, a specification for one component. Now we are talking, and we have to think about the overall system. How does the overall system topology look like? And then balance, basically between the components.
So not a component provider, but a solution delivery right now. So that is kind of a new task for you. Since we're here in our IAA special edition of the MAHLE Mobility Talks, I guess that it's really a tough, speaking of challenges, a tough challenge for thermal management when it comes to these, let's say, these extreme application fields of trucks, for example, sandy roads or really long distances to drive. What does this mean for thermal management in particular?
What we foresee is that the variety is not really coming, what you just described, basically from the use case. Of course, you have to pay attention if we're talking about construction vehicles which are operating in dirt area, because
or
then
deserts.
or deserts, because then maybe your heat exchanger is also polluted. But the variety on the truck side is really coming from the variety of drive terrains, what we see. And this has different demands to the thermal management system. And as I mentioned, we see on the delivery transportation sector, there will be purely battery electric, medium heavy duty vehicles, where we have to provide a thermal management system which suits exactly a battery electric vehicle. But when we are talking, and you just mentioned this example, when we are talking about long haul trucks, where we will see fuel cell applications in the future, the cooling demand of a fuel cell truck is much, much higher than from a combustion engine. Sounds in the beginning a little bit crazy, because everybody think, okay, that's about electromobility, and this guy was talking about that there's not so much free energy available anymore. But the question, or the challenge at fuel cell trucks is to maintain, similar like in the battery, also a certain temperature for the fuel cell stack. And this temperature where a fuel cell stack operates in an efficient window is at much lower temperature than in a combustion engine. You know, from your car, you're driving your car and you see, okay, my nominal cooling temperature, if you ever look at this small thing, is somewhere
definitively all the time.
is somewhere between 90 and 100 degrees Celsius. And in a fuel cell truck, we are somehow operating between 70 to 80 degrees Celsius. And now it's a little bit about physics. It's about when your outside temperature is high and your cooling temperature, which you have to provide, is at a lower level, then your temperature gradient is basically lower, and therefore you need to transfer much, much more heat to the outside. And that's a challenge for fuel cell trucks, because at the end of the day, you have a truck, but maybe you have no more space available for all the heat exchangers.
So is that a way to say, okay, these are more or less temperature tolerant, these technologies? Or is it like, okay, this is not just about the technology itself, it's about the whole ecosystem, and then you can say it's more tolerant or less tolerant?
Yeah, it's really about, when you're talking about the ecosystem, it's really about how does the topology in the drivetrain look like, and this will be then decisive for the design of the thermal management system. And basically, it's really about how to do it in the most efficient way. And when I was talking about this variety, what we expect, especially on the commercial vehicle side, for us, and that's, I think, in our industry, in the supplier industry in the moment, the biggest challenge is about how to provide the right technology for the right segment and to provide a kind of a more modularized approach, because you cannot invest in all of that different segments. So therefore, it's important to have a kind of a base concept which you then can provide to different applications.
And above all, to do this in a very sustainable and efficient way, of course. So next level challenges, I guess.
No, but basically that is in our industry. That's in the moment one of the big challenge is really also in regard, and that's our. I think that's all of our responsibilities, how to make it sustainable, also in regard of the. Not only to do it in an efficient way afterwards in the vehicle, but also to consider this already in the production. And that is really a decisive factor how, and that's then something which is going back to the design. How can you design heat exchanger that the energy which is consumed to produce the heat exchanger is as low as possible? And that's one of the biggest challenges what we have right now.
One of the biggest challenges. So let's do a little forecast. If I were a fairy and I could solve one of your big challenges, and I see there are a lot of, what would you wish for in terms of thermal management?
My wish for thermal management system.
Yeah, just to, if I were a fairy and I could solve any of these big problems, what kind of problems should I solve for you? And I have to mention I'm not a fairy, but just in a theoretical way.
One of the biggest challenge what we foreseeing in the moment, and there you could help me tremendously if you could forecast for me the share of the different drivetrain concepts of the future. That would make it for us much more easy in the development, because then we could focus on special technologies, and with the variety what we see in the moment, it's quite a challenge. And if you could provide me there a good forecast, that would be one of my dreams.
Yeah, so let's see what I can do for you and how much it costs you. So thank you so much, Roger, for all these insights and for all these learnings in thermal management. And of course, thanks for tuning in and for staying here with us. And if you want to learn more about technology and mobility, just check out our channel. And of course, we have another talk here, another MAHLE Mobility Talk at IAA. So check out this video as well. And yeah, hope to see you soon. Take care and bye-bye.